In this video, we're given a diagram A, B, C, and D, which is having a known size x and y. So from the first question, we have to find the value of x and y. The second one, we have to find the perimeter of ABCD. Then the last one, we have to figure out the area of ABCD. Now, considering ABCD, we could see that it is a right triangle. And with that, I think that information is going to help us find the value of x, because if ABCD is a right triangle, then to find the value of x, this x, we can apply the Pythagoras rule, which says that if you have a right triangle like this, then if here is R and here is P and here is Q, then the Pythagoras theorem says that R squared will be equal to P squared plus Q squared. And observing the triangle ABC, we can apply that rule. So in applying that, we are going to just do some substitution. X squared from the diagram, comparing to the Pythagoras theorem, this is going to be the hypotenuse, or it corresponds to the R, right? We're going to have x squared equal to RP, which is 4 squared, plus RQ, which is what? 3 squared, right? Then over here, you can have x squared equal to x squared equal to 4 raised to the power 2 is what? 4 times 4, which is 16. What about 3 squared? 3 squared means 3 times 3, right? 3 times 3 is what? 9. Okay, so 16 plus 9, what do we have? We have 25, but we're looking for x, and this is x squared. So what do? We're going to, find the square root of both sides. We're going to have square root of x squared equal to square root of 25. And this square root of a means a raised to the power 1 and 2. Okay, so this square root is going to cancel the exponent of our x. So we're going to have, x, because the square root of x squared is going to give us x. We're going to be x squared times 1 and 2. And then the 2 cancel, 2 times 1 is going to give us 2. So we're going to have x 2 over 2, and 2 over 2 is going to be what? 1. So we're going to have x raised to the power 1 by x raised to the power 1 is equal to 1, x. Right, and then the square root of 25 is going to give us 5. You know how we had a 5? What number can you multiply by itself to get 25, which is 5, right? 5, 25. So the square root of 25 is 5. Okay, having done finding the value for x, then the next figure is going to be the value for y. And also looking at BCD, right? This right, this sign here at this particular point shows that the angle at the C, BCD, the angle BCD is what? 90 degrees. And if BCD is a triangle and there is one of the angles be 90 degrees, then we can confidently say that this is also a right triangle. And since it is a right triangle, we can find the value of y if we know two sides of the right triangle. We have worked and we saw that x is equal to what? Just found out that the x is 5. So if x is 5, then we have BC. We also have the CD to be 12. All what we need is what? The y. But the y is going to be our hypotenuse comparing to the Pythagoras rule that we just worked here. Our r will be y, our q will be 12, and our p will be 5, right? So, working that, using the Pythagoras theorem to find the value of y, you're going to say that y squared will be equal to this side, 5, right? Yes, 5. So 5 squared plus the other side, the side which is what? The CD, 12. So we're going to have 12 squared, right? So y squared will be equal to 5 squared is 5 times 5. And that's going to give us 25. And then 12 squared means 12 times 12. That is 144, right? Then our y squared will be equal to 25 plus 144. That's going to give us what? 4 plus 5, that's going to give us 9. And then 4 plus 2, that will give us 6. And we have 1. Okay, now we're looking for y. But this is y squared, so what are we going to do? We're going to square both sides. So y squared we're going to find the square root of both sides, right? So y squared, then we apply the square root, and then 169, we apply the square root to it. So just as we did for the x, the square root means raised to the power half. So the square root is going to deal with this square. So at this side we're going to be left with y, okay, because the power of y is going to be 1, and y raised to the power 1 is going to be 1. The square root of 169 is going to give us 16, right? 16. So from the diagram, x is distance, right? Y is also distance. So our if we say that we should find y, we can confidently say that therefore x is equal to 5 centimeters and our y is equal to 13 centimeters. So we're done finding x and y. Now the next one says that we should find the perimeter of ABCD, right? So to find the perimeter of ABCD, then what we got to do is that perimeter of ABCD, that's II. So the perimeter is the distance around a shape, okay? Distance around a shape, which is going to be AB, BD, DC, and CA. Okay, so we're going to have the perimeter to be AB plus BD plus DC or CD, right? CD then plus AC, right? So AB on the diagram, what is AB? On the diagram, AB is 4 centimeters, right? 4 centimeters. So we're going to have AB 4 centimeters plus BD. What's BD from the diagram? From the diagram, BD, which is our Y, we had Y to be equal to what? 13 centimeters. So our BD is 13 centimeters, right? Okay. Right. So BD 13 centimeters plus CD. CD, I think that's known already on the diagram. CD is what? 12 centimeters, and AC or CA is what? 3 centimeters. Please, the BC is not part. The perimeter means the distance around a shape, right? So we don't include the BC because the BC is within the shape. It is not around the shape, right? Cool. So that CD is 12 centimeters and the AC is what? 3 centimeters. Let us write them there. Try to do the computation. So we have CD 12 centimeters plus AC, which is 3 centimeters. Then we do the addition. If you add 12 and 13, what are you going to get? Going to get 25, right? 25 plus 4, what do you have? Have 29. 29 plus 3, that is 32. So we're going to have 32 centimeters, right? And perimeter, your answer is going to be labeled as centimeters because it is distance. So therefore, perimeter of A, B, C, D is equal to 32 centimeters, right? Now let us look at the last one, which is the area. The area, figure out the area of ABCD. Now, you know, this one is a composite figure because we have two triangles, right? This is ABC is a triangle, BCD is also a triangle. So we're going to find the area of triangle ABC. After that, we find the area of triangle BCD. Then we add them to get a total area of ABCD, right? So the formula for finding the area of a triangle is what? Half base times height. And for triangle ABC, our base is what? 4 centimeters, and our height is 3 centimeters. Okay, so let us do the computation. That is I area of triangle is equal to half base times height. Okay, so we're looking for the area of triangle ABC, and then the area of triangle ABC is going to have times our base, which is 4. The base is what? 4 centimeters, right? AB. Okay, let me write it like this. It's going to be half times AB times AC. Okay, so this implies half. What is our AB? Our AB is what? Distance AB AC. AB from the diagram is 4 centimeters, right? AB 4 centimeters. So we're going to have times 4 centimeters times the AC. What is AC? AC is what? 3 centimeters. So we have 3 centimeters. And half of 4 is going to give us what? 2 centimeters times 3 centimeters. And this gives us 2 times 3 is going to be 6 centimeters times centimeters is going to give us centimeters what? Squared. Right. So having found the area of ABC, then we're now going to find the area of BCD. And for that one too, our height is what? CD, our base is CB or BC, right? Cool. So the area of BCD is going to be half of BC times CD, right? And then BC is what? Half times the BC. Let's check BC. BC is 5 centimeters, and our CD is what? 12 centimeters, right? So we're going to have 5 centimeters times 12 centimeters, and then half of 12 is going to be what? 6, right? So we have 5 centimeters times 6 centimeters. 5 by 6 going to give us 30 centimeters square. Right, now define the area of ABCD. Area of ABCD is going to be equal to the area of ABC plus the area of BCD. What's the area of ABC? The area of ABC is what? 6 centimeters, right? So we're going to write 6 centimeters squared. Sorry, it's 6 centimeters squared, not 6 centimeters. Then the area of BCD is what? 30 centimeters square. 30 centimeters square. 30 centimeters square, which is in total going to give us what? 36 centimeters squared. Right. So easily we're done finding the value for x and y, which is x 5 centimeters, y 30. Our perimeter, we had 32 centimeters, and our area of the figure, we had 36 centimeters squared. Thank you.